Okay, I started out with asking Andy, or Andy answered. I said, why do we want to scan for open ports? And then somehow we got around to that we want to see what ports are open. Because any port that's open is a vulnerability. A port means that it's accepting communication somehow. If we have a web server, for example, that only is serving something out on port 443, we don't need other ports open. We only need port 443. So when you start closing down ports and shutting off services, that's called hardening. You're hardening the attack, you're decreasing the attack vector, you're hardening the server, so there's no extra stuff going on. So Microsoft with Windows Server and Linux does the same thing. Nothing is installed and running until you tell it to run. Like Linux will have a bunch of stuff installed, but it's not running. You have to say, okay, run this web server. You know, like Kali Linux has a, what is it, Apache web server built in it, but it's not running until you make it run. So there's no operating systems have gone to the don't do anything unless you have to model, which is the least principle of least privilege goes everywhere. You want to, I was reading another article last night that zero trust. That's it. I was reading, or maybe it was somebody's thing on maybe it was a Think-A-Lot where somebody put that in here, but zero trust is another way of saying the same thing. Don't trust anybody. You know, make sure they are who they are. You know, zero trust is a good place to start from. Then you start saying, okay, we can open this port because this is something we do need to have open. So we're going to build our own little port scanner because that's a good way. I like building little things in Python because Python is the scripting language of cybersecurity and ethical hacking. Plus, I think it's a really good way to understand what is actually happening because we have to put all the little parts down in code. And Python has a built-in library called socket. Well, what's a socket? What is all that about? Did we ever talk about what makes up a socket before? I don't know if I've ever used the term socket.
In Linux, it's widely used.
Well, it's used everywhere. A socket is you have the name, for instance, you have a URL. Here is the name of our computer, wncc.edu. Right, and it comes, no, actually, this is the host. This is our domain, sorry. This is our domain. Here is our actual computer, www is the name of the computer. That's the host name. We are delivering that information from, oh, I'm pointing around. Anyway, it's 443 because it's secure. So a socket is the entire connection down to the port. It's the location of it, it's the server, and then you add the port on the end of it. That creates a socket connection. Socket connections are used in TCP/IP to allow communication with a specific application. Like anytime you're browsing to a secure website, the browser knows to automatically in the background append 443 because that's the commonly used port for SSL TLS. If we're doing email, well, the commonly used port for that we discovered last week for encrypted email is, remember our little email stuff we've been doing? What's the port for encrypted? 587. And we're using TLS, so that's 587. TLS is transport layer security, which encrypts at a lower level than SSL does. So that entire path, it's one way to think about it, down to the socket number tells us the application that should be contacting us. Remember our layers? We have the layer 1 is the physical, layer 2 is the MAC address, layer 3 is the IP address, layer 4 is the you can think of it as it's the transport layer, but that's where the socket occurs. So we have to have all those pieces to say we're connecting to this machine at that specific port. So that means that's the hole in our window that things are going through. It's the chimney that things are going through. It's the, I don't know what else. I can't think of a good analogy, but it's the entire connection. And then on that port, we create a socket connection, and socket connections we typically use TCP for socket connections because TCP is,
Transport controlling. It's
yep, transport control protocol. And what type of transport control protocol is it? What's the difference between that and UDP?
It makes sure that all the data is consistent, all delivery.
It's reliable.
Yeah.
It always does its thing. So you always have a socket connection.
Mhm.
That socket connection is like you're handshaking, you're making sure that you're getting stuff back and forth, and it's on a particular port. So this, you're advertising, so to speak, to the browser that, oh, this is where I'm supposed to connect. The browser knows that. All right, so we hard coded a host and I used 8.8.8.8. I'm hoping that they don't mind if we do a little scanning. We're only scanning one port, so I figure we're okay doing port 443. We really should not be scanning that. From in here, I think we'll be scanning, let's scan our server. So that's my, oh no, that one's down right now. There it is. There's one of my servers. 10.11 is one of my active domain controllers. We could also scan the firewall. Well, in this case, we're picking a particular port. This is going to be a very ineffective port scanner because we can scan port 443. Then we have to change it to scan port 444. Then we have to change it to scan port 445. And that's just going to take a long time, isn't it? Oh, let's try this. I wonder if we can get to this from inside here, because that does have a port 443. Anyway, if whatever you try doesn't work, try something else. But this is an illustration of what's going on. So we need to create a sock object, which is like a socket object, but we can't call it socket because socket is the name of the library. So we have to call it something else. So the socket part of the socket library, and the socket library has all kinds of stuff for communicating through TCP and UDP. We have to say, what is our address family? Because MAC addressing, we can't send a packet by MAC address normally. You can if you dive down with SCAPI, but not with a normal socket connection. You can't do things with MAC addresses. That happens automatically. The socket lives at it starts at the third layer 3. That's where sockets start. And layer 2 is MAC addresses, and MAC addresses happen in the background for this sort of connection. All right, so we have to say socket dot, well, kind of addressing are we using? Well, we could use AP. Look at this, they have IPX and all kinds of stuff here. Well, we don't use AppleTalk. This is DECnet. This is all ancient technologies, but they included in there. We want INET.
Mm-hmm.
And notice they have INET 6, but AF INET 6 is the address family for IPv4.
INET 6 is? Or,
INET 6 is version 6.
yeah.
But at the time they developed this socket library, there was only IP version 4, I'm sure, because this library has been in Python for a long time. Otherwise, they probably would have put AF INET 4. It is still pretty much the default protocol that we use, I mean, for IP addressing. So then we have to say, okay, that's our layer 3 protocol. Then we have to do what's our next layer protocol, which layer is that? Transport layer. Whoops, I did the wrong one. It's the transport layer. So the transport layer, oh, it has a SO, I don't know what some of these mean. See, key underscore stream, there we go. So sock stream, when you do a TCP connection, can think of it like a binary stream. Information is streaming out, it's streaming in. It's actually much like printing. In Java, some of the ways that you do socket connections, you use print commands to print to the socket. Regardless, that's beyond this scope of this right now. Now we're saying this is the type of socket connection we're going to make. We're going to use IP version 4. We're going to use TCP. It's a streaming protocol because we're streaming bytes. Now we have to determine, did we make a connection or not? So if sock.connect, because when you try to make a connection, either you make a connection or you don't. And so we want to determine that if we make a socket connection, And we're gonna say, we wanna put in the horse, oh, this is a tuplet, sorry. Let me get that out of there. So this sets up the socket. This makes our connection to the host and port that we have mentioned up here. Oh, what am I doing now, Ron?
You got a
Closing
bracket.
parenthesis.
You're missing a bracket.
Oh, I'm missing I'm missing a parenthesis. There we go. Because this is a tuple. I don't know why it's a tuple. It just needs a tuple. Probably to enforce that we need a host and a port. You can't make a connection without both. You have to have both of them. So I'm not gonna do the whole thing, but I'm just gonna say is closed. If connection fails, which is a non-zero return value, meaning anything other than zero, so this kind of sounds backwards, doesn't it? Oh, print closed. That means nobody responded, nobody's home. Otherwise, which is what else means, otherwise, port is open. Print. There we go, print. Port is open.
What about filtered ports?
Hmm?
What about filtered ports?
How are you filtering it?
That's just what the seventh and third type filtered ports, like with firewalls and stuff.
When you filter a port, you might filter it by IP address coming in, maybe you're not gonna allow certain IP addresses to come in. You can't like filter out port 443 because you want to accept connections on it. So filtering would be, like for instance, from inside the network, I might say, you can use any other port to go out on the network, but I don't want you to use 895. So you'd be filtering out port 895, but the outside of the firewall is always set up on a zero trust thing, meaning nothing's open unless you need it.
Yeah,
So you're filtering everything else out except port 443.
I understood that. I'm just wondering, well, if a port is filtered, what would come back as filter open?
Closed. Yeah, because you won't have a response.
Okay.
Well, let's see if we can get to lab.w. I think we can. We'll find out. Oh, it worked. I had to do some DNS stuff in here because we're inside the same network, but the port is open. So I could use that for this lab instead of 8.8.8.8. Because I know 443 is open because I have a web server on that port. It is open, but you can see this is not going to give us a very robust scanner, is it? We have to change this number every single time, but this does show how it works. We set up IPv4, which a host resolves to IPv4. DNS resolves it to an IP number. We've set this specific port. We've said we're doing TCP. Does UDP use ports? Sure. It uses ports. It just doesn't do a sock stream. It does something else. I think there's another one.
Datagram.
Yeah, that's it, datagram. It does a datagram. So it's throwing things out and hoping things stick. That's what it does. All right, so now we want to be able to set in a few more parameters. So one of the parameters, unless we want to wait forever, is to put in a default timeout. So I'm moving on to the next one. So socket dot set default timeout. So this will speed up the scanning process. Typically, unless the server is under a huge amount of load, it should come back in a quarter of a second. But then you can change that, you know, that's how long it'll wait for a response. It'll wait a quarter of a second, move on. And if it takes longer than a quarter of a second, it's probably the server's overloaded. So instead of doing this, we want input. We know how to do input. If you type input with lowercase, it'll do input. So enter host name. I'll just say enter host name. You can finish up your thing and make it look nice later. I'm going through the principles of how this works. All right. So we can enter the host name. We can enter an IP address, host name or IP, either one. That'll work fine. We still create an IPv4 socket, but we're not going to scan only one port. we're going to create a list of ports and go through them one at a time and check them all off. Well, not check them all off, but go through them. We're still gonna use this guy here. And at the end, because a programming language doesn't directly access any hardware, a programming language accesses the operating system. The operating system opens up that resource for us. And it's very nice, just like with SQL and when we do file operations, when we do something that requires use of the operating system, it's always good to close up the resources afterwards. Otherwise, it could just hang out, and that's where memory leaks come from. But I still haven't put in the part where we're going to go through things. So what kind of a for loop allows us to go through whatever numbers that we want? For port in range. The range function allows us to do one I to J, which means we can go from 1 to 50,000 or whatever we want to do. The while loop is if we don't know how long we want to go. In this case, we know we want to go start at 0. I don't know if there's actually a port 0, but we'll start at 0. 0 to 1024, what are called the commonly used ports or something like that. Those are the ones that are commonly used.
Well, no.
Well known. Yes, that's right. Well known. Well, those are well-known ports. So where does the port come from? Well, you have to spell port, right? And there we have it. Now, this is not a threaded program, is it?
No.
I've never tried to thread this one because, yeah, I think you could have multiple sockets open at this. Yeah, you could have multiple sockets open at the same time. I've just never threaded this one before. Yeah, Andy?
Shouldn't the socket close be out of the loop?
Yeah.
That's a good question. I don't know. I had it here,
It
so.
goes after running the first port.
Yeah, yeah,
Yeah, we don't need to close it every time.
because we just need to change where we're going with it. Yeah, we just close it at the end. Yeah, that makes sense. It still works the other way because we're creating a new socket here. No, maybe we aren't.
We are not creating it inside the loop. It will close it and then blow up.
Yeah. Did all that. Everybody's closed. Oh, but I forgot to print the IP, didn't I? Let's see, we'll do port. And we'll do IP. And if you put a colon between it, that's kind of the normal designation of how you do a socket. You know, doing that, host colon port. There.
And little F before the string.
Oh, yes, you're right. I need the F string in there. Thank you, Mike. There. And that might be different than what I did on the thing, but this is oh, I did do the colon. I did do the standard way to, that's how you do a socket. That shows the different sockets that we opened up. And there really shouldn't be anything open on this from 0 to 1024, except 443. Now, do we need to have to go through all these stupid things each time? How would we fix this so we don't have to scroll through the whole thing?
Show only open ports.
Right. So to do that, if it goes into here, there's a couple different ways to do that. One of the things we learned is continue. Right? If we continue and we go into here and we continue, nothing happens. That's one way to do it. I could also change my if loop around and not have an else too, right? I can move my test, I can test differently here, but now it should just show the open port. I don't think I did that in the lab, did I? Uh-oh. Nothing's coming back. Uh-oh, what happened?
So it continued and it completely skipped over the loop.
So just like we did with our Plink plotter, this could be threaded. And I did discover that I had an error when I was typing things in. We do have to create and delete our socket, close our socket for each connection. because it's a separate connection. I now remember this when I put this together. So we have to create and close a socket. Create a new socket for the new connection. Because that's what happens when you're communicating. You have to create that socket for each port, and then you close it. And then you create a new one, and then you close it. Oh, and look at my example here. My example shows that I made the change that we just made, but I don't have it. I don't have it in my code. So this should be like continue. What I think I'll do is put this upside down. Let's redo our code here.